Okay, Assalamualaikum and hi everyone. So basically I'm going to show you how to solve the example 3. This is from our lecture on axial deformation. Okay, if you refer to Timothy book, it's actually the example 5.3. Okay, so this is the problem. We have a rigid bar ABC and it is supported by post 2 and also rod 1. Okay, and there is the external load which is 30 kN that is applied at point D of the rod 3. Okay, so our job here is to determine the vertical deflection of joint D caused by this external load. Okay, so you know the step. We start with we use a method of section. Okay, method of section to find the internal force. Okay, so first step is always find the internal force. So how to find the internal force is just you use method of section, draw the FPD equation. Okay, so let's start. So this is our rigid bar. Okay, so we draw the FPD for the rigid bar. Okay, using method of section. So and here is the FPD lah. Okay, and always we assume the F is in tension. Okay, so F1, F2 and F3, and by looking at the problem, we know the F3 here is equal to P, which is equal to 30 kN. Okay, so and let's take the equilibrium equation, the force equilibrium first. Okay, so we assume that upward is positive, so negative F1 minus F2 minus F3 or 30 kN equal to 0. So minus F1 minus F2 equal to 30 kN. Okay, next is moment equilibrium at point B. So we assume that counterclockwise is positive. Okay, so the distance between point A and point B is 2.4 meter. So 2.4 times F1, and distance from B to C is 1.8. So and it is clockwise, so minus 1.8 F2 or 30 kN, which equal to 0. So you should get your F1 equal to 22.5 kN. Okay, so this is your F1. So just substitute the F1 into this equation here. You should get your F2 equal to negative 52.5 kN. Okay, so you can see that your F1 is actually in tension and your F2 is compression. Okay, so now we get our the internal force, so we can calculate the deformation. Okay, so start with rod 1. The delta 1 is equal to F1 L1 A1 E1. Okay, just substitute all the value into this. The unit is consistent. This is important because it will affect your end result or your calculation. Okay, so just substitute the value. You should get the deformation of rod 1 is 9 mm. Okay, so you can see that the rod 1 is actually elongated. Okay, and now for the post 2, the delta 2 is equal to F2 L2 A2 E2. Okay, so you should get your delta 2 is equal to negative 7 mm. So you can see that this is caused by the compressive force, okay, F2. Okay, and lastly, the deformation in rod 3. Okay, delta 3 equal to F3 L3 A3 E3. So you should get your delta 3 is equal to 10 mm. Okay, so rod 3 also is actually elongated. Okay, so let's draw or sketch what happened to the bar, to the rigid bar, when when all the posts and rod this is the initial position, okay, before the deformation. So at point A here, okay, this is post or rod 1, okay, it is elongated by 9 mm. Okay, so let's say this is 9 mm. So delta 1 is equal to, we can say it is equal to VA, the displacement at point A, this A, okay, which is equal to 9 mm. Okay, and this is a point A, and then at point B here, this is post 2, okay, at point B, and we know that post 2 is contracted. It's contracted by 7 mm. Okay, going downward by 7 mm. So delta 2 we can say equal to VB, the displacement at point B, equal to 7 mm. Okay, alright, and lastly, before that, let's sketch, okay, the position of the bar after the deformation, something like that lah. Okay, this is rough sketching. Okay, alright, now the rod 3 also elongate with 10 mm, okay, by 10 mm. So let's say this is the initial length, and then it's elongate with 10 mm here. So now we want to find the at point C, or displacement at point C here, so that we can sum up. Okay, this is VC, displacement at point C, or deflection at point C. So that we can sum up VC here to get the total deflection at point D. Okay, so this is what we now find. Total deflection at point D. Okay, at point D. So we have to add VC and also 10 mm. Okay, so now what we want to do next is to find VC. Okay, let's say this is the position, the length of P lah, the length of this rod 1 and also post 2. Okay, alright, so now find VC, then the problem is solved. Okay, so let's find VC. So let's sketch what happened to the bar after the deformation. Okay, so the rod 1 is elongated by 9 mm, okay, upward at point A, and post 2 is contracted by 7 mm downward. Okay, if we sketch this, it will give you something like this. Okay, so this is at point B, this is at point C. So basically we want to find VC here. Okay, so here is VA, here is VB. Okay, so how to find VC? Basically we use triangle ratio. Okay, what we can do here is actually we can move this line here to this point. Okay, we can move to this point. So let this sketch. It will give you something like this. Okay, all right. So this line here is basically VA plus, okay, this line here, okay, VA plus VB. Okay, so here is VA plus VB, and this line here is basically, you want to find this line, right? So the whole length here is VC. So VC minus VB. Okay, minus VB. Alright, now we can write other ratio. Okay, VA plus VB over this length here is 2.4 is equal to VC minus VB over 1.8. The length here is 1.8. Okay, so this is 2.4, this is 1.8. Okay, so just rearrange this. You should get VC equal to 1.8 over 2.4 VA plus VB plus VB. Okay, so you know that your VA is 9, VB is 7. Okay, so just substitute the value. You should get your VC equal to 19 mm. Okay, so we have our VC. Now we can get the deflection at point D. Okay, so deflection at point D is basically VC plus the elongation of bar 3. Okay, so VC is 19 mm, elongation of bar 3 or rod 3 is 10 mm. So you get your VD or deflection at point D equal to 29 mm. Okay, so that's all. Okay, it's quite straightforward. The only part that is a little bit tricky is this part. Okay, this this part here. Okay, you have to think a little bit. Okay, how to rearrange the triangle so that you can form your ratio. Okay, so if you still have any problem or any confusion, you can ask me. Okay, that's all. Thank you for your attention. Bye.